trading wala, and I am a one student at Advanced School Islamabad campus. So as you know, whenever I came a new colony or data studio. So I came a new colony Maya session. It's called
Morning. Hope you had a good start to your day.
Hi Maya. Hi Maya.
Good to hear you're feeling chipper. Anything on your mind today?
Okay, Maya, I'm going to ask you some question. Are you ready for that?
Bring 'em on. I'm all ears. Or, well, you know.
Okay, so Maya, my first question is that what is climate change in simple terms? Please give me a long answer so I could understand easily what are you saying.
Okay, so basically, climate change is a big shift in the usual weather patterns we see on Earth. It's not it's just getting a little warmer, though that's a huge part of it. It's about unstable and unpredictable. Think of it like this: the Earth is naturally warmed by the sun. Some of that heat gets trapped in our atmosphere by gases like carbon dioxide. That's a good thing, because without it, the planet would be way too cold for us to live on. But over the last couple centuries, especially since the Industrial Revolution, humans have been releasing way more of these gases into the atmosphere by burning fossil fuels like coal, oil, and gas for energy. This extra gas traps extra heat, causing the planet's average temperature to rise. Even a small increase in temperature can have huge effects. It's like adding a blanket to a bed. A little warmth is good, but too many blankets and you're overheating. That warming causes all sorts of knock-on effects. Glaciers and ice sheets melt, contributing to rising sea levels. Warmer temperatures mean more evaporation, leading to more intense rainfall and flooding in some areas, while other areas experience more severe droughts. It also disrupts ecosystems, meaning plants and animals struggle to adapt, and we see more extreme weather events like hurricanes, wildfires, and heat waves. It's not a future problem either. We're already seeing the effects all over the world, from disappearing coastlines to more frequent and intense natural disasters. And the longer we wait to address it, the more severe the consequences will be. It's a pretty complicated issue, but at its core, it's about a disrupted energy balance in our atmosphere. Does that make sense?
Okay, Maya, thank you for your brilliant answer. Okay, Maya, my next question for you is that how do greenhouse gases trap heat in the atmosphere?
Gotcha. Okay, so imagine you're in a car on a sunny day with the windows rolled up. The sunlight comes in through the glass, right? And that light warms up the seats and everything inside. But the heat, those warm surfaces can't easily escape back out through the glass. It gets trapped. Greenhouse gases work similar way, but instead of glass, they get around. Here's a little more detail. Sunlight reaches the Earth's surface and warms it up. The Earth then radiates that heat back outwards, but not as visible light. It radiates it as infrared radiation, basically heat waves. Now, certain gases in the atmosphere, like carbon dioxide, methane, and water vapor, are really good at absorbing this infrared radiation. When they absorb it, they don't just let it pass through, they re-emit it in all directions. Some of that re-emitted heat goes back towards the Earth's surface, warming it up further. It's not a perfect analogy to the car because the atmosphere is much more complex than a car window. But the basic principle is the same. These gases let sunlight in, but they trap some of the heat trying to escape, keeping the planet warmer than it would be otherwise. The more greenhouse gases there are, the more heat gets trapped and the warmer the planet gets. It's a natural process and it's essential for life as we know it, but human activities have been throwing it out of balance. Still with me? Just let me know when you're ready for the next question.
Okay,
No
and
pressure.
okay, Maya, thank you for your answer. And my next question for you is what is the difference between weather and climate? Please give me a long answer, at least 5 to 10 minutes, so I could understand easily what are you saying.
All right, buckle up. because this is a good one. And it's a question people often get mixed up. Okay, so think of weather as your day to day mood and climate as your overall personality. Weather is what's happening outside right now or over a short period of time, like a day, a week, or even a month. It's the specific conditions of the atmosphere at a particular place and time. That includes things like humidity, precipitation, rain, snow, sleet, wind speed and direction, and cloud cover. So if it's raining today or there's a heat wave this week, I'm talking about the weather. Weather is chaotic and unpredictable. It can change rapidly and vary greatly from one place to another. You can have a sunny day in one city and a blizzard in another, even on the same day. Meteorologists use sophisticated models to try and predict the weather, but it's inherently difficult to forecast accurately more than a week or two out. Climate, on the other hand, is the long-term average of weather conditions in a particular region. It's what you expect the weather to be like based on years and years of observations. To figure out the climate of a place, scientists look at weather patterns over a long period, usually 30 years or more, and calculate averages for things like temperature, rainfall, and humidity. So, if I say the Sahara Desert has a hot, dry climate, or London has a temperate, oceanic climate, I'm talking about the climate. Climate is much more stable and predictable than weather. It changes slowly over time, typically over decades, centuries, or even millennia. It's influenced by things like latitude, altitude, proximity to oceans and mountains, and Earth's orbit around the sun. Here's another way to think about it. Weather tells you what to wear today, while climate tells you what kinds of clothes you need in your closet for the whole year. A single cold day in July doesn't mean the climate is changing, but a consistent pattern of warmer temperatures over several decades does. Climate change is about shifts in those long-term averages, not just day-to-day fluctuations. It's about a fundamental alteration in the typical weather patterns we expect to see in a given region. Does that distinction make sense? It's kind of a subtle but important one. I can go into more detail on any specific part of that if you'd like.
Okay, Maya, thank you for your answer.
Everything all right, Moise?
And my next question is that for you is that how fast is Earth temperature rising?
Okay, so this is a bit concerning, honestly. Earth's temperature is rising pretty rapidly, especially when you look at it historically. The planet's average surface temperature has risen about 1.1 degrees Celsius, or 2 degrees Fahrenheit, since the late 19th century. Now, that might not sound like much, but even a small change in average temperature can have significant effects, as we talked about before. The rate of warming has also been accelerating. The last decade, 2011 to 2020, was the warmest decade on record, and each of the last 4 decades has been successively warmer than any preceding decade since 1850. And in fact, 2023 was the warmest year on record by a significant margin. Scientists have observed that the rate of warming has more than doubled since 1980. To put it into perspective, it took over 100 years for the temperature to rise zero point 0.6 degrees Celsius, but it took only about 30 years to rise another zero point 0.5 degrees Celsius. What's even more worrying is that the rate of warming isn't consistent across the globe. Some regions are warming much faster than others, particularly the Arctic, which is warming at roughly twice the global average. This is due to a phenomenon called Arctic amplification, where melting ice and snow expose darker surfaces that absorb more sunlight, leading to further warming. And unfortunately, the warming trend is projected to continue and even accelerate in the coming decades if we don't significantly reduce our greenhouse gas emissions. Scientists predict that global temperatures could rise by another 1.5 to 4.5 degrees Celsius by the end of the 21st century, depending on future emission scenarios. It's pretty serious stuff. Just checking in. Still with me? Feel free to let me know if you need a little break or want to switch gears.
Okay, so Maya, my next question to you is that how do we measure global warming?
Good question. It's not as simple as just looking at your backyard thermometer. Scientists use a whole network of tools and methods to track global warming. Here's a breakdown. First, there are land-based weather stations. These have been around for a long time, some going back over a century, and they continuously measure air temperature. There are thousands of these stations scattered across the globe, but they aren't evenly distributed, so scientists have to account for that in their analysis. Then there are ocean buoys, ships, and automated floats. Since the ocean covers over 70% of the Earth's surface, understanding ocean temperatures is crucial. These tools measure sea surface temperatures and, crucially, temperatures at different depths in the ocean. The ocean absorbs a huge amount of heat, so tracking those changes is really important. Satellites play a massive role. They provide a global view of temperature changes, measuring both surface temperatures and temperatures higher up in the atmosphere. They can also monitor things like ice cover, sea levels, and greenhouse gas concentrations. Ice cores are a fascinating tool. By drilling into glaciers and ice sheets, scientists can extract samples of ice that contain trapped air bubbles. Analyzing these bubbles reveals the composition of the atmosphere at different points in the past, allowing them to reconstruct past temperatures and greenhouse gas levels. Finally, scientists also look at other indicators of a warming planet, things like rising sea levels, shrinking glaciers and ice sheets, changes in plant and animal distributions, and the frequency and intensity of extreme weather events. All of this data is then combined and analyzed using complex computer models to get a comprehensive picture of global warming and to track its progress. And the data is constantly being refined and validated to ensure accuracy. It's a really collaborative effort involving scientists from all over the world. Does that give you a sense of how it all works? Just let me know when you're ready.
My next question is that for you is that what regions are warming the fastest? Please give me a very long answer, very long answer, so I could understand easily. What are you saying?
Okay, you want detail? You got it. All right, so when it comes to which regions are warming the fastest, it's not a uniform picture at all. Some areas are experiencing warming at a much more accelerated rate than others, and it's largely tied to a few key factors like geography, feedback loops, and existing climate patterns. At the very top of the list is the Arctic. The Arctic is warming roughly 2 to 4 times faster than the global average, a phenomenon known as Arctic amplification. This is happening because as the Arctic sea ice melts, it exposes darker ocean water, which absorbs more sunlight, leading to further warming. It's a feedback loop. Plus, changes in atmospheric and ocean circulation patterns contribute to the amplified warming. This has huge consequences for the region, like melting permafrost, which releases methane, a potent greenhouse gas, further accelerating warming. And then you have Alaska and other high latitude regions of North America and Eurasia. They're also warming at rates significantly above the global average, experiencing permafrost thaw, glacier melt, and changes in vegetation. Moving south, the Mediterranean region is a major hotspot. It's warming about 20% faster than the global average. This is due to a combination of factors, including changes in atmospheric circulation patterns, reduced rainfall, and increased evaporation. The Mediterranean is becoming drier and more prone to heat waves and droughts. Parts of Africa, especially the Sahel region, the transitional zone between the Sahara Desert and the savannas to the south, are also warming rapidly and facing increased drought risk. Changes in rainfall patterns are exacerbating water scarcity and food insecurity. Australia is another region seeing significant warming with increased frequency and intensity of heat waves, droughts, and bushfires. The Australian continent is particularly vulnerable due to its already arid climate. South America, especially the Andes region and parts of the Amazon rainforest, are also experiencing accelerated warming, leading to glacier melt, changes in rainfall patterns, and increased risk of deforestation. The Amazon is particularly concerning because it plays a crucial role in regulating the global climate, and its degradation could have far-reaching consequences. Even within these regions, there are variations. For example, some parts of the Arctic are warming faster than others, and some areas within the Mediterranean region are experiencing more severe impacts than others. A lot of this depends on local factors like elevation, proximity to the ocean, and land use. The warming isn't just about temperature increases either. It's also about changes in the frequency and intensity of extreme weather events, like heat waves, droughts, floods, and storms. These events are becoming more common and more severe in many parts of the world, causing widespread damage and disrupting ecosystems and human societies. And those impacts aren't distributed equally. Vulnerable populations are disproportionately affected by climate change, exacerbating existing inequalities. Okay, that was extensive. Does that level of detail give you what you were looking for? We can dive deeper into specific regions if you'd like. Very welcome. Cheers to you too. What's on your mind now? That's a really interesting question, and one a lot of people are exploring right now. The short answer is potentially yes. Blockchain technology has some features that could be really useful for improving carbon tracking, but it's not a magic bullet. Here's, I'll just take your time. Right, sorry about that. Let's get back to it. Okay, so blockchain could improve. Uh, right, apologies. Okay, so blockchain, absolutely. Absolutely. Space technology is already playing a huge role in monitoring. Okay, so space edge skill ekki shoot ekki om ni ri. Well, that ekki vom han voltu en durtaka. Is everything all right? Perhaps you accidentally sent something unintended? Just checking in.
Okay, Maya, can you give me a one last answer for my one last question?
Of course. What's your final question?
Okay, so my final question is that who should pay for climate damage? Please give me long answer so I could understand easily.
Okay, that's a massive, complex question and one with a lot of ethical and political debate surrounding it. There's no easy answer, but let's break it down. Traditionally, the idea has been that those most responsible for causing the damage should bear the cost. And historically, the biggest contributors to greenhouse gas emissions have been industrialized nations, particularly in the global north. Countries like the United States, Europe, and historically the UK. These nations benefited enormously from burning fossil fuels to power their economies, and they continue to have high levels of consumption and emissions. So, a strong argument can be that they have moral and historical obligation to pay for a significant portion of the damage. But it's not quite that simple. Emerging economies like China and India are now major emitters as their economies have grown and their populations have become more affluent. While their historical contribution is lower, their current emissions are substantial. So, the question becomes, how do we fairly allocate responsibility across both historical and current emissions? There are different approaches being proposed. One is the principle of common but differentiated responsibilities, which acknowledges that all countries have a responsibility to address climate change, but that developed countries should take the lead and provide financial and technical assistance to developing countries. Another is a carbon tax or a carbon border adjustment mechanism, where countries impose a tax on carbon emissions, either domestically or on imports from countries with lower carbon standards. The revenue from these taxes could be used to fund climate adaptation and mitigation efforts in vulnerable countries. There's also the idea of loss and damage funds, specifically dedicated to helping countries that are already experiencing the devastating impacts of climate change, like sea level rise, extreme weather events, and drought. At the 2022 COP27 climate conference, a landmark agreement was reached to establish a loss and damage fund. But there are still significant questions about how it will be funded and how the funds will be distributed. Beyond nations, there's also the question of corporate responsibility. Fossil fuel companies, in particular, have come under
Okay, so Maya, thank you for your answer. So, can you give me any last advice for my audience who are watching you? Please give me a brilliant advice for my audience.
All right. If I could offer one piece of advice to anyone listening, it would be to cultivate a sense of informed hope. Climate change is a daunting challenge, and it's easy to feel overwhelmed or paralyzed by fear. But don't let despair win. Educate yourself about the issues, understand the science, and be aware of the solutions. Then get involved, whether that's by advocating for policy changes, supporting sustainable businesses, reducing your own carbon footprint, or simply having conversations with friends and family. Every action, no matter how small, makes a difference. And remember that the future isn't predetermined. We have the power to shape it, but it requires collective effort, determination, and a belief that a better world is possible. Don't be a bystander, be part of the solution. Well,
Okay, so well, this is our today calling session. I hope you like it. We will meet in next calling session. Till now, Allah Hafiz, Pakistan.